We'll start our video here. Just like there are exponent laws, for every exponent law, there is a corresponding law for logarithms. So for example, do you remember a product law for exponents? If you multiplied and had the same base, what did you do to the exponents? You added them. So multiplying powers with the same base added the exponent, there is a similar log law. And in logarithms, what happens is that if you are multiplying inside of a logarithm, it is the same as adding the logarithms. And in fact, the example that I just showed you can be explained with this log law. Remember, I showed you that log 8 of 4 plus log 8 of 16 is equal to 2. Well, what am I doing here? I'm adding two logarithms. I have the right-hand side of this log law. I'm adding two logarithms with the same base. The log law says that I would be allowed to multiply the 4 and the 16, and this is exactly the same. And if I did that, you see that you would get log base 8 of 64. And now the answer being 2 makes a lot more sense, because 8 to the exponent of 2 is equal to 64. So if you have an exponent law that says same base, add the exponents, you now have a log law that says same base adding logs is like multiplying inside the logarithm. Remember your exponent law for dividing? If you have the same base and you're dividing, you could subtract the exponent. Well, there's a log law that says if you're dividing inside of the logarithm, you can just change that to subtract it. And in exponents, we have a power to a power. When you had an exponent to another exponent, you would multiply. In logarithms, it says if you have an exponent inside your logarithm, you can take that exponent and bring it out in front and multiply. So all of our exponent laws have a corresponding log law. And you can play around with your logarithms and actually prove each of these if you want to. We won't do it in class today, but all of these log laws are on your formula sheet, and you'll have to know how to use them just the same way that you use your exponent laws. Oh, in fact, they even have a proof of one of the log laws for you on page 389. So log laws act like identities. You can switch from left side to right side and right side to left side whenever you want. So when we get to example 1 here, example 1 uses the word simplify, and in your log laws, we consider the left-hand side of your log laws to be the simplified version. So if I am adding two logs, I have the right-hand side of one of my log laws that says if you add two logs and the bases are the same, and you see how there's no base written here, which means that both of these have a base of 10, then you can combine them by multiplying inside the logarithm. So maybe I'd take one extra step. I did this 8 times 7, and I would get log of 56. So this is using the log law, which is on your formula sheet, that looks like this. And on your formula sheet, they don't use any numbers. But what's important to notice is that I'm adding, so I see the adding right there on the right-hand side of my formula. In the formula, my bases have to be the same, and since there's no base written here and no base written here, they both have a base of 10, so that fits. And if it matches up perfectly, log plus log, bases are the same, then I can change it to the left side, and the left side is always considered the simplified side. I could change it to multiply. So we need to have our log laws memorized so that we recognize them. Part B. Is there a log law with a number in front? Yes. You have the following log law that says log A of m to the n is equal to n log A of m. So here is where we have a number in front. And that number in front can go in as the exponent to the left-hand side. So part B, I could rewrite this as log 2 to the 5, which 2 to the 5, if I wanted to multiply that out, that's 32. And finally, part C, is there a log law that we're subtracting? Yes, on the right-hand side. On the right-hand side, if you're subtracting and your bases are the same, so our bases are the same, and I'm subtracting, then I can combine it as a single logarithm by dividing. So this one would become log, and no base is written, so it's a base 10 of 80 divided by 16, which if I simplify that, is just 5. Questions for practice on this one? Part 4 and 12. So what you're going to find in this section is I introduce you to these new log laws, and now we're going to take some time to practice them with no real purpose in mind, it seems. Trust me, there is a purpose in mind. But we're just practicing this weird manipulation, and we're supposed to get good at it. And we're going to find out why it's important to get good at this in a bit, because we're going to find out how we can use logarithms to solve a lot of real-life world problems and a lot of algebraic problems. But before we can solve those problems, we have to get really good at all of these log laws and playing around and manipulating them. And sometimes we'll want to simplify. So sometimes you're going to have the right-hand side of these formulas and want to change it to the left-hand side of the formulas. And sometimes we're going to have the left-hand side and want to change it to the right-hand side. And we're going to see all of those situations coming up. But right now we're just practicing and getting good at them.